Hello, this video will teach you linear programming and how it relates to life.
Linear programming will help you solve a problem that goes something like this.
Wow, that's a lot to think about. Well, thank God for linear programming, because linear programming is a process of optimization based on your constraints to get the best possible outcome. Now, let's break up linear programming into easier bites.
We will talk about objective function, constraints, feasible region, and optimization. Let's start with an easy problem.
We'll start with the bicycle manufacturing problem, found on page 165 of your Algebra 2 book. Opened right up to it. That's awesome. Okay, so this problem is called bicycle manufacturing. Two manufacturing plants make the same kind of bicycle. For the two plants combined, the manufacturer can afford to use up to 4,000 hours of general labor, up to 1,500 hours of machine time, and up to 2,300 hours of technical labor per week. Plant A earns a profit of $60 per bike, and Plant B earns a profit of $50 per bike. How many bicycles per week should the manufacturer make in each plant to maximize profit? Now we need to find our objective function and label our variables. Let's start with the variables. Let plant A equal x, and x is the number of bikes produced in plant A. Plant B will be labeled y, and that will be the number of bikes produced in plant B. Sorry about that.
Next, we have to find the objective function. The objective function is equal to C and deals with profit. Plant A earns $60 a bike, so that's 60x. Plant B earns $50 a bike, so that's 50y. Profit C equals 60x plus 50y.
Now that we have our objective function, the next step is to label our constraint. So, our constraints for the first couple are really easy. And these constraints are x is greater than or equal to 0, because we're not going to make negative bikes, and y is greater than or equal to 0 for the same reason. Now the next next three constraints are kind of related to hours, where the hour, well, let's just start with the general labor, which is 4,000. Both plants together can make make bikes for up to 4,000 hours. So that will be 4,000 is greater than or equal to, because on this side is the amount of labor. In this case, we'll have Plant A has 10 hours per bike for general labor, and Plant B has 1 hour per bike. The next constraint deals with technical labor, 2,300 hours, again greater than or equal to. The Plant A takes 5 hours per bike, and Plant B takes 2 hours per bike. Our next constraint is machine time, which is 1,500, again being greater than or equal to the amount of labor we put in. For the machine time for Plant A, that's 1 hour machine time, and Plant B, it takes 3 hours to make one bike for machine time.
Okay, well, we have the equations, but what do we do with them?
Well, person who asks obvious questions who knows the answer to them, we graph these constraints.
Okay, well, don't we need to set them equal to y first?
Yes, we do. Why don't you do that? Now, hopefully you're doing this on a white line paper, and not a really small whiteboard, so yours will be much neater than ours. Obviously, this equation goes with this equation goes with this, and this equation goes with this one. So just graph them and see what it looks like. This area right here is called our feasible region. So with this, we move on to our next step. Oh, and it's important to note that the intersections of each line are vertices. Right here, 0, 500, 300, 400, 380, 200, 400, 0, and 0, 0. Now, you may be wondering why we solve for the objective function. We haven't used it yet. Well, now is the best time to use it, and pretty much the only time to use it. You plug in your vertexes for each one and solve for each vertex. So let's just list the vertexes right now. Obviously, we have a minimum right here, so it wouldn't be good to make nothing of either. And our maximum profit comes from this equation, from this vertex right here, which came from this vertex.
Finally, make your answer into a sentence. In order to obtain the maximum profit, the bike company should make 300 bikes in Plant A and 400 bikes in Plant B.
So there you have it. That's linear programming. Now, if you want to follow us into more detailed the cookie problem and help us solve that, come see our next video. If you think you got a grip on it, there's some practice problems at the end with answers to them. And that wraps it up. Thanks for watching.